In Chapter 8, we're going to be looking at quantities in chemical reaction. And by quantities, we mean amount, and the amount that we're going to be looking at are moles and mass. In a balanced chemical equation, the amount of every substance used and made is related to the amounts of every other substance within that balanced equation. The study of the numerical relationship between chemical quantities in a chemical reaction is called stoichiometry. So Chapter 8 is all about stoichiometry. And probably the easiest way to think about stoichiometry, or amounts in a chemical reaction, is to think about a recipe. And let's look at making pancakes. A very simple recipe here. We have 1 cup of flour, 2 eggs, and half a teaspoon of baking powder to make 5 pancakes. In a chemical reaction, this over here, this side would be our reactants, and this would be our product. And this would be a combination reaction or synthesis reaction, since we only have one type of product, or pancakes. Let's look at the mathematical relationship between these different substances. 1 cup of flour is equivalent to 2 eggs, equivalent to half a teaspoon of baking powder, is equivalent to 5 pancakes. We need this exact ratio to get this amount of product. Now, if we wanted to make more or less than 5 pancakes, we can use the number of eggs or the amount of flour or baking powder we have to determine the number of pancakes, assuming we have enough of the other ingredients. So let's assume that in our pantry we have 5 bags of flour and 10 cans of baking powder. We have more than enough flour and baking powder, but we only have 8 eggs and we have company. How many pancakes can we make? Well, we know from our recipe that 2 eggs gives us 5 pancakes. This comes from our recipe, and we're going to use that to see if we have 8 eggs and 2 eggs gives us 5 pancakes. Our eggs cancel out, and when we do the math, 8 times 5 is 40, and 40 divided by 2 is 20. We get 20 pancakes. So this relationship between pancakes and eggs gave us our final answer. And if we look back at our original recipe, this makes sense. Our relationship between eggs and pancakes is 2 to 5. If I have 8 eggs, or 2 times 4, I'm going to have 5 times 4, or 20 pancakes. It's still a 2 to 5 relationship. 8 to 20 is the same as 2 to 5. Now, we are going to be doing the same thing, but instead of using a recipe, we are going to be using a balanced equation. Let's look at this balanced equation. This balanced equation tells us we need 3 molecules of hydrogen to react with 1 molecule of nitrogen to give us 2 molecules of ammonia. And we need exactly this amount of each chemical. Now, when we were balancing equations, it was fine to think about these these coefficients as molecules. However, in reality, it's impossible to isolate 3 molecules or 1 molecule or even 3 million molecules. They're so incredibly tiny. So now that we're going to be talking about actual amounts, our coefficients are now going to stand for moles, because moles are measurable amounts. So when we read this equation from now on in this chapter, instead of saying 3 molecules, we're going to say 3 moles of hydrogen react with 1 mole of nitrogen to produce 2 moles of ammonia. And like our pancake recipe, this is our mathematical relationship. For this particular chemical reaction, 3 moles of hydrogen is equivalent to 1 mole of nitrogen is equivalent to 2 moles of ammonia. We need exactly these amounts for our balanced equation, or our recipe. So let's look at a typical example. Sodium chloride, NaCl, forms by the following reaction between sodium and chlorine. So here's our balanced equation, and you should be able to write this if you weren't given it. If you weren't given this balanced equation, here's sodium, here's chlorine. Sodium always forms a +1 charge. Chlorine always forms a -1 charge as chloride. So it's a 1-to-1 ratio of cation to anion. Okay, let's get to our question. How many moles of sodium chloride result from the complete reaction of 3.4 moles of chlorine? Assume that we have more than enough sodium. Okay, so here we have a question where we are given information about one chemical. We're given information about chlorine, and we're asked to find out information about a different chemical. Anytime that is the case, we're going to have to use a balanced equation to get our answer, and that's what's known as stoichiometry. In stoichiometry, you must have a balanced equation. That's our recipe. The given chemical must be in moles. If it's not in moles, we have to get it to moles. But in our case, the previous example, we already have it in moles. Then what we're going to do is we're going to use the mole ratio. This mole ratio is from the balanced equation to get from the given chemical to the desired chemical. So this is the key. This is how we get from one chemical to a completely different chemical. We use our recipe or our balanced equation. And then our answer for the desired chemical will be in moles. So the first thing we want to do, we want to keep our balanced equation nearby, and then we want to write down what we're given and what we want. We're given moles of chlorine, we want moles of sodium chloride. And again, anytime we're given information about one chemical and we want information about a different chemical, we need a balanced equation. Then we need our conversion factor, and according to our balanced equation, 1 mole of chlorine is equivalent to 2 moles of sodium chloride. So what we're going to do now is our railroad math. Okay, we're going to start off with what we're given, which is 3.4 moles of chlorine. And here's our conversion factor. Our moles of chlorine go on the bottom, and then our moles of sodium chloride go on top. Our moles of chlorine cancel out, and we end up with moles of sodium chloride. So using the relationship from our balanced equation, we were able to get from one chemical, chlorine, to a new chemical, sodium chloride. And our answer is 6.8, and if we look at our sig figs and our given value, this is the correct number of sig figs that we want. And so there's our final answer. Now we always want to check our answer to make sure it makes sense. We have twice as many moles of sodium chloride as we do chlorine, and that makes sense if we look back at our balanced equation. It is a 1 to 2 mole ratio. For each mole of chlorine, I have 2 moles of sodium chloride. So I should get twice as many moles of sodium chloride. So our answer makes sense.